Hi, welcome to Math After Hours with Miss Austin. I'm Miss Austin, a math teacher here to help you with your math questions. And today we are looking at elimination. We're looking at elimination with a 3x3 system of linear equations. Now, sometimes these can be a little daunting, but I love these. I don't know why. I love substitution and elimination. This was the one thing in school that I could just do all day. I'm like, don't give me anything else, just give me these. So the problem we're looking at today is this one right here. Now, the first thing you want to do when you're starting is look at your variables x, y, and z and decide which one do I want to get rid of first from every single equation. Well, if I'm looking at these equations, sometimes I like to pick x just because those are in the front. But take a look at these y's. This one in the middle is a positive 1y, so you could also make that anything you want by multiplying this equation by a number. So I'm just going to pick to eliminate y. It really doesn't matter. You can choose whichever one you want, and you'll end up with the same answer. What I like to do is I write at the top, eliminate y, because sometimes when you're eliminating y from the first two equations, then sometimes when I would go to the second two, I'd accidentally eliminate a different variable and then they didn't line up correctly. So this is just a way to remind myself I am eliminating y from all of the equations. So if I label my equations 1, 2, and 3, what we're going to do is split up the equations into 2 and 2. How do we do that? We only have 3 equations. There's always one equation you're going to use twice. You can pick whichever equation you want. For me, to be consistent, I always like to use the second equation twice, but it's up to you. So when I set this up, I'm going to put 1 and 2 over here. So x minus 2y plus z equals negative 5, and 2x plus y minus z equals 6. Then I'm going to use equation 2 twice, so I'm going to put 2 and 3 over here. 2x plus y minus z equals 6, and 3x plus 3y minus z equals 11. Okay. So with each of these two equations, we're going to eliminate y. If I look at these first two, I want to be able to add the two equations together to completely get rid of y. Right now, if I add them together, these will not go to 0. But what if this was a positive 2y? Then they would cancel. So what I'm going to do is multiply this whole equation by 2. The first equation stays the same. And then the second equation would become 4x plus 2y minus 2z equals 12. And now we add the two equations together. And we would get 5x, the y's cancel like we wanted, minus z equals 7. Okay. Now I'm going to switch over to the other two equations. We're going to come back to this in a minute. So switching to these two equations, again, I want to eliminate y. And again, this is why I wrote eliminate y at the top, because before I've made mistakes where I go over to the first two, eliminate y, and maybe I go over to the second two, eliminate z, and then I'm like, I'm stuck. You need to eliminate the same variable from both. So again, that's why I like to write that at the top. So if I want my y's to cancel, this is a positive 3y. What if this was a negative 3y? Then they would cancel. So I'm going to multiply this whole equation by negative 3. So the top equation would become negative 6x minus 3y plus 3z equals negative 18. And then we didn't change equation 3. And now we can add them together. And we would get negative 3x, y's cancel, plus 2z equals negative 7. So let's come back out for a second. The two equations that I have circled in blue have variables x and z. And this is what we want, because now what we can do is actually bring these together and create just a 2x2 system. So we will have 5x minus z equals 7, and negative 3x plus 2z equals negative 7. And you've probably done systems like this before, and now we just want to get rid of x or z. Doesn't matter, you can choose which one. Looking at these two equations, I think z might be a little bit easier to get rid of, so that's what I'm going to do. So right here, if this is a positive 2z, I can pretty easily make this a negative 2z. It's already negative, so all I need to do is multiply that equation by 2. And then bringing that down, we'd have 10x minus 2z equals 14, and the second equation is not changing. If I add these two together, 10 minus 3 gives us 7x, the z's cancel, and that's equal to 7. And now we can solve for x. We'll just divide by 7 on both sides, and x is 1. From here, we're going to do back substitution. You cannot go to one of your original equations yet because you only know x. We need to find another variable first before we go to the top. So what you want to do is come back to this 2x2 system you had. We only have two variables here, and if we know x, we can find z. It doesn't matter which equation you use. So let's say I use this one right here. So if 5x minus z equals 7, then that would be 5 times 1 minus z equals 7. 5 minus z equals 7. I'm going to subtract 5 to the other side, so negative z equals 2. And dividing by a negative, z equals negative 2. Okay, now we have x and z, so we can go back up to the original equations and use one of the three to solve for y. It does not matter which one of these three we pick. It's really up to you. I might choose to just use the first equation. X minus 2y plus z equals negative 5. So x is 1, I'll plug that in. We don't know y. Z is negative 2, it's equal to negative 5. Combining these two, we have negative 1 minus 2y equals negative 5. Adding 1 to the other side, we get negative 2y equals negative 4. And divide by negative 2, and we get y equals 2. So we have our solution, x equals 1, y equals 2, z equals negative 2. You can also write your answer in what's called an ordered triple, x, comma, y, comma, z. And that is how you use elimination to solve a system of 3 linear equations. I had a lot of fun, so at least I did, even if you didn't. I appreciate you watching, and please like and subscribe. If you have any questions you would like me to do, please comment them below.